Hello boys and girls, question 5. We have a vertical brass rod of circular sections, okay? It's loaded by placing a 5 kg weight on top of it. If its length is 50 centimeter, okay, the length of the brass rod is 50 centimeter, radius of cross sections is 1 centimeter, and the Young modulus of the material here is brass, is 3.5 to the power of 10 Newton per meter squared. We want to find the contraction of the rod, the energy stored on it. So I visualize the problem. So we have a brass, the original length or the length of the brass rod is 50 centimeter, change it to meter, means it's times 10 negative 2 meter. And it have a radius of cross-sectional area, so the radius is given by 1 centimeter, so 1 times 10 negative 2 meter, change it to SI unit. So this rod is made of brass, whereby the Young modulus is given by 3.5 to the power of 10 Newton per meter squared. So I put a 5 kg weight on top of it. So I put a 5 kg weight on top of it. Okay, I have 5 kg weight put on top of the brass. So what are going to happen? We know that these 5 kg weight are going to have weight. So this weight will act as the compressive force. Okay, it will act as the compressive force. So the weight 5 kg will act as the compressive force, whereby these compressive force are going to press on the rod. So what are going to happen? The rod will contract. Contract here means decrease in length. Because of the compressive force. So weight 5 kg ni akan mampatkan rod tu. So because of these compressions, there will be a decrease in length. There will be a decrease in length of the rod. So we need to find the contractions, how much is the decrease in length of the rod. Okay, so since we are given the original length, so the original length teacher put is at L0 lah, L0. Then we know the compressive force. We are given the Young modulus. So I can use the equation for Young modulus to solve for the questions. So Young modulus is stress over strain. Stress is force over area. Strain is along the contractions here, the decrease in length here. So kita tidak boleh panggil benda tu sebagai extension ke elongation dalam situasi ni lah, kelas. Kita tak boleh panggil benda ini sebagai elongation ke extension, sebab sekarang kita tidak ada pemanjangan, tetapi kerana compressive force kita ada contraction, decrease in length. Tapi kita masih guna simbol yang sama lah. Kita masih guna simbol E ya. Okay, so strain will be the contractions over the original length. So I rearrange. I'm going to have S L0 over AE. So this is the equation to calculate the Young modulus. So the compressive force here is the weight of the load 5 kg. So force here is weight adalah mg, mass darab, the acceleration due to gravity, original length L0 over the cross-sectional area. How we find for this cross-sectional area? So this is the cross-sectional area of the rod. So the cross-sectional area is a circle, so the area will be pi r squared multiplied with the contraction E. Okay, so we want to find for the contractions of the rod. So we have to rearrange our equations. So I want to find for the contractions, so it will become mg L0 over pi r squared Young modulus y. So then we can put in all the value lah. Mass is 5, g is 9.81, original length is 50 to the power of negative 2. Pi, the radius is 1 to the power of negative 2 squared. Young modulus is 3.5 to the power of 10. So you might pause the video to calculate the value of contractions. So the contractions or the decrease in length because of the compressive force will be 2.23 to the power of negative 6 meter in micrometer. So the decrease in length is very small. So it's not that noticeable to our naked eye lah. So guna mata kasar actually kita tak berapa boleh observe decrease in length tu lah sebab nilai dia sangat kecil sahaja. Okay. Dan we done question A, we move on to question B. We want to find the energy stored in it. So as what I already explained in the summary concept video, first video. So one that is the extension or contractions due to the tensile force or the compressive force, actually we do what? So we are going to store energy. The energy stored here will refer to the strain energy. The strain energy. So we want to find for the strain energy. So how we find for strain energy? So take out the equation for strain energy. Strain energy is half Fe. Okay, half Fe. So the force, the compressive force here is the weight mg. Then we already get our contractions of the rod. So we put in the value. Mass is 5, g 9.81. The contractions is 2.23 to the power of negative 6. So pause the video to do your calculations. 3, 2, 1. So we get the U will be, the strain energy will be 5.47 to the power of negative 5 joule. So energy, so the unit will be joule. Okay. Then we solve questions B.